Hey everyone, and welcome back to the channel. Today, we're rejourneying to one of the most mysterious places in our solar system, the far side of the moon. You've probably heard it called the dark side, but is it really always dark? And what incredible secrets has it been hiding from us all this time? Let's find out. First, let's clear up a common misconception. The dark side of the moon isn't actually dark. It gets just as much sunlight as the side we see. The reason we never see it from Earth is due to a phenomenon called tidal locking or synchronous rotation over billions of years. Earth's gravity has slowed the moon's rotation so that it spins on its axis at the exact same rate. It orbits our planet. This means the same hemisphere is always facing us. A better name for it is the far side of the moon. For most of human history, this far side was a complete mystery. We had no idea what it looked like. That all changed in 1959. During the height of the space race, the Soviet Union's Lunar 3 probe swung around the moon and snapped the very first grainy, black and white images of the hidden hemisphere. The world was stunned. What they saw was a landscape dramatically different from the familiar face of the moon. The near side, the one we see, is dominated by vast, dark, smooth plains called Maria, which is Latin for seas. Early astronomers mistakenly thought they were actual oceans. We now know these are ancient volcanic floodplains, but the pictures from Luna 3 showed that the far side had very few Maria. Instead, it was almost entirely covered in craters. It was a rugged, battered, and ancient-looking world. This immediately raised a huge question. Why are the two sides so different? For decades, this remained one of the biggest lunar puzzles. NASA's Apollo missions provided some clues. The Apollo astronauts, who all landed on the near side, brought back hundreds of kilograms of lunar rocks. Analyzing these rocks revealed that the crust on the near side is significantly thinner and has a different chemical composition than the far side. This difference in crustal thickness is the key. Scientists now believe that when the moon first formed, it was a hot ball of molten rock. Because of the tidal locking, the near side was constantly facing the still scorching hot early Earth. This intense heat from our planet kept the near side molten for longer. This allowed heavy, radioactive elements like uranium and thorium to concentrate on the near side. This concentration of radioactive elements acted like a planetary oven, keeping the mantle beneath the near side crust hotter for much longer. Because it was hotter, it was easier for magma to punch through the thinner crust and flood the surface, creating the vast Maria we see. On the far side, away from Earth's residual heat, the crust cooled and thickened much more quickly. It became too thick for magma to easily break through. So, instead of being resurfaced by lava flows, the far side simply collected billions of years' worth of impact scars, resulting in the crater-saturated landscape we see today. It's like a preserved record of the early, violent history of the solar system. Fast forward to the modern era of exploration. We've sent numerous orbiters, like NASA's Lunar Reconnaissance Orbiter, or LRO, which have given us incredibly detailed maps of the entire lunar surface, including the far side. These maps have revealed some spectacular features. One of the most mind-boggling is the South Politcon Basin. This isn't just any crater. It's one of the largest and oldest recognized impact basins in the entire solar system. It's absolutely massive, about 2,500 kilometers, or 1,600 miles, in diameter, and over 8 kilometers, or 5 miles, deep. An impact of that scale would have been cataclysmic. It was so powerful that it may have punched clean through the moon's crust and dredged up material from the lunar mantle. For geologists, this is a scientific goldmine. Studying this basin is like having a natural drill hole into the moon's interior, offering us a chance to understand its fundamental composition and evolution without having to dig. But the far side isn't just a place for looking back in time. It's also a perfect place for looking out into the cosmos. Here on Earth, our radio telescopes are constantly bombarded with noise from our own planet. Television broadcasts, radio stations, Wi-Fi signals, you name it. It's a cosmic cacophony that drowns out the faint whispers from the early universe. The far side of the moon is the most radio-quiet location in the inner solar system. The entire bulk of the moon acts as a natural shield, blocking all of Earth's radio interference. This makes it the absolute perfect place to build a radio telescope to listen for the faint signals from the cosmic. Dark Ages, the period right after the Big Bang, before the first stars ignited. Setting up a radio observatory there could revolutionize our understanding of how the first galaxies formed and how the universe came to be. It's one of NASA's long-term dreams, and we've finally landed there. In 2019, the Chinese National Space Administration's Chang'e 4 mission made the first ever soft landing on the far side, touching down inside the von Karman crater, which is within the giant South Politcon Basin. This was a monumental achievement. Because there's no direct line of sight to Earth, the mission required a dedicated relay satellite positioned in a special orbit beyond the moon to bounce signals back and forth. The Change Philander and its rover Yututu have been exploring this alien landscape ever since. They've used ground-penetrating radar to see beneath the surface, revealing layers of dust, broken rock, and ancient lava flows. They've analyzed the composition of the soil, confirming that it seems to be different from the near side, possibly containing some of that deep mantle material splashed out by the giant impact. One of the rover's most intriguing discoveries was a strange, gel-like substance found in a small crater. The images sent back showed a shiny, dark, greenish material that looked different from the surrounding soil. After careful analysis, scientists concluded it was most likely impact meltbretsia, rock that was shattered and melted by the intense heat and pressure of a meteorite impact, then cooled into a glassy, dark shard. While not an alien gel, it's another fascinating piece of the puzzle of the far side's violent history. So, the far side of the moon isn't a dark, sinister place hiding alien bases, as some sci-fi movies would have you believe. It's a treasure trove of scientific discovery. It holds the secrets of the moon's formation, a pristine record of the solar system's chaotic youth, and offers a unique window to the dawn of the universe itself. The missions there are just beginning, and what we continue to find on this hidden side of our celestial neighbor will undoubtedly reshape our understanding of the cosmos. What do you think's the most exciting thing about the moon's far side? Let me know down in the comments. And if you enjoyed this journey to the other side of the moon, please give this video a thumbs up and subscribe to the channel for more deep dives into the wonders of space. Thanks for watching, and I'll see you in the next one.